Hey yogis, welcome back to the next session on Anubhav Learning series. In our previous part of this video series, we have discussed about how to create an OData service on top of CDS views using CDS entity reference technique, how to support eTag for an OData service using SAP Gateway system. SAP Gateway system provides a powerful management for eTags automatically, and that's something out of the box. You just have to make the metadata changes to be able to tell which is the field is going to behave as an eTag. And that's it. System takes care of all the management of the eTag, including if match condition to be able to find out whether there was a changes in the eTag field or not, and accordingly decide whether to allow update or not. Now in this series of video, in this section of the video, we will discuss about how to handle the concurrency as well as optimistic locking in the ABAP system, and also comparing this eTag to decide whether to do an update or restrict users to do an update. So this video we will focus once again on ABAP side, coding and managing the locks, intermediate locks, which are optimistic locks for the time of call of update entity set, and also making sure that if the eTag is changed over a period of time where due to concurrent updates, we are going to throw an exception to the end user. Once again, I would request, if you have not seen the previous two parts, please find the link in the video description over here and look back the parts of the missing parts, the part 1 and part 2 of this video series into my YouTube channel or Anubhav Learning series, exclusively available free of cost on onlinefioritrainings.com. There are amazing videos available on different topics like CDS, ABAP on HANA, S4 HANA Technicals, UI5 Fiori Gateway Launchpad. You can also subscribe to my online Fiori trainings, which are find out when is the next batch planned and accordingly decide and book your seat before your competitor does that. All right, let's go ahead and now see how can we implement the locking as well as the concurrency support with the help of the ECAT supplied by the user interface. So in our last video, we have created this OData service, and here you can see the output of this OData service exposing one entity, ZOFTLSC sales order, and that was built with the help of a CDS view. And now we will move to the DPC extension class where we will be writing very first support. Okay, let me just note down here the steps, what we are planning to do. The very first thing, if you observe guys, we have multiple entity sets as part of OData service. So you can see in total, we have total 4 entity sets over here. And by default, what system does is whenever an update is being fired, system is going to check for eTag availability in every post request, update request with these entity sets, all of them. We don't want that to happen. We want the system to check eTag availability only and only for this particular entity type. Other entity sets and other entity types, when they are being involved into any kind of CRUD operation, we don't want that to be considered as part of our operations. So in that case, we have to make a small change as part of our metadata class, as part of our DPC class, to be able to tell the system, hey, please do not enable the eTag checks on other entities. Please enable it only and only for this particular entity. So for that, we will go back to DPC class and find out a method. The name of the method is called getIsConditional. Okay, that's the method you got to check. So let's come back and check the method getIfConditional, and you can see getIsConditional implemented. That's the method we are going to write. So basically, this method we are writing to check the condition if the entity set which is currently being involved is our entity set which is built on top of CDS. Is that the entity? And also only on that entity if the update and create has been fired. So what we got to check, we just have to look at the signature here, and you would find there's already a couple of input parameters by default Gateway is giving. That's the beauty of Gateway system. And I just put an if condition, and if my entity set name is equals to, and let me just gonna go back and pick it up the entity type, and that's my entity set. Actually, we're gonna pick up the entity set name and put that over here, and we'll see if this is the entity. Along with that, the operations which we are going to perform are update operations or they are patch operations. Only in that case we should allow eTag checks. Otherwise, we should not even care about eTags, because then in that case it's something else which is happening on the entity, and we should not really care about it. So now here you can see the operation type checks, which we can compare with the gateway available gateway constants. All the gateway constants are available in a gateway class called IWBEP, IFMGW Apple types, and in that we have GCS global constants for operation type, and if it's an update operation, it's an update entity, or let's copy that up. If it's a patch entity. Yeah. Only in that case we need to enable and tell the system the conditional checks should be activated. So that's my output parameter. Else it will be false. Awesome. So that's the check, guys. An important check here to make it side effect free and not affecting other entities. We want to make sure that the eTag check is only enabled for our entity, which we are using for update sets. All right, so let's activate this very important method. So this was one question I've received in my previous video from one of my students, and this is the answer of that question: how can we restrict eTag checking only pertaining to our entity rather than bringing the side effect to other entities? Yeah. So that's one change, quick change, and now we are going to go back and go back to the update method where we are going to implement an optimistic locking. If you're not aware of what is optimistic locking, I would again request you to please watch my previous video, and you can find the link into the description of this video. Where is that video? The previous video where I have explained and discussed about optimistic locking. What does it mean in REST-based architecture? How can we use eTags to make sure that concurrent updates can be managed pretty well? All right, let's come back to update entity. And now this update entity needs to be fired only in certain cases, only when we really need, really need the update, and when the eTags are not changed. Only in that case we got to fire that. All right. So in my last video, I have already implemented this update entity set method, and let me just quickly brief you through the code once again. Just a quick recap. So what we do here is this method is going to be used to update the data. Yeah. So we are actually updating the description of the sales order. And for that, we have created a couple of data declaration and then just reading the key value passed for update as well as the payload. Now, once we found that, we are going to push that into a BAPI, which is a ready-to-use BAPI offered by SAP as part of NetWeaver 7.4 SAP EPM data model. Pass that up, and that gets the data updated. If we check, there is no return, which means everything was smooth and data got updated. But what about locking? What about eTag management? We have not done any code right now in the last session about handling the eTags, checking if the eTag is matching with the last provided eTag to the client machine, and if that doesn't match, throw an exception and don't allow the update to happen, right? All that stuff, we haven't done that right now. So first of all, I'm going to do a couple of data declaration. So I've got a couple of data declaration, and I will also do data declaration to be able to manage my lock arguments. So for that, I will write data, and I'll say begin of my ls snwd lock. I'm basically declaring a data structure for preparing the properties and attributes to be able to perform optimistic lock on the object, on the sales order in this case. The object is sales order in this case. So sales order will be identified by the node key, which is of type snwd underscore lock hyphen node key. That's a parameter. The next, I'm basically creating this structure to identify my object. So do name, and then it's of type snwd underscore lock hyphen do name. And the next property is BO node name. And then comes is your client field. All right, awesome. So these are all couple of arguments which I've created, guys. Once again, you can find in the description a link which can also be used to download this complete source code which I've written here. So this source code will be readily available to you, and you can download and put that in your system and then test whether it works as expected or not. All right. So that's what you all guys can do. So now let's move on, and now we will be writing a quick algorithm. The steps with which we will be implementing the entire locking mechanism as well as checking for the etags which is supplied by the client. All right, let's come here and write down the step. The very first step which we need to do is we need to check if the given sales order exists. Yeah. Point one, very important, guys. Let's say in concurrent environment, there are two users who are using same sales order. One of the user loaded the sales order, and at the same time, another user also loaded the sales order. Now, the second user is supposed to update some data on the sales order. At the same time, the first user has already deleted their sales order, right? So that's concurrency exactly. So you have two clients here, two users. So this is my Fiori app 1, which is running by user 1. And this is where my client 2, which is my Fiori app 2. Same Fiori app running in a running by different user. And on the server side, I have my server, which is now being receiving the request from these two Fiori applications, which has no clue about each other, that both of them are accessing the same sales order or not, right? So we don't have that knowledge at this moment. And now they are using same sales order. The one client one request for the sales order, server responds that, client two request for sales order, and server also responds to client two. And now both of them are able to see the sales order. Now, while the client 2 is updating some data within the sales order, this guy here, this gentleman client 1, fires a delete request. It says, hey, please delete the sales order. In that case, what happens? The sales order is already deleted, but that is not notified to the client at this time because it's a stateless communication. So on the client 2 side, we already have that sales order currently visible on the UI. And now user thinks that they would probably need to update something, and then say, okay, fine, I've updated the data, please save. On save now, and a put request goes in, and boom, it doesn't find that record because already in the meantime deleted by user 1. So how do you manage this case? Point 1, concurrency. So you got to manage a code to be able to check if the order exists, and if it doesn't, then probably throw an error. Then throw an error. Exception. That's what you got to do. Wow. So that's step number 1. Step number 2, what we need to do, after finding it out, whether it is existing, we need to proceed further. We need to now try to put a lock. So try to lock the sales order. Don't lock the whole table, guys. At times I see some developers, they do not understand locking mechanism and they lock the whole table, and then no update can be done on entire table. Be careful. You have to make an optimistic lock, and it's a record level locking which you have to achieve. Okay, and that's the reason we have implemented that is structure, which just now I've written in the code, to be able to pass the exact node key, exact key of my sales order in it, to be able to lock that exact entry rather than locking the whole table, right? So that's what we got to do. So we have to try to lock the sales order which was requested for update. And if you try to acquire a lock, and if the lock is not successful, if acquisition of lock fails, we have to throw an exception. Yeah, that's what you got to do. Step number 4, after throwing, if it is able to lock it, then what you got to do, you have to now read the last updated date and time value. That's basically what we are also treating as a eTag. So if the lock is successful, then we have to proceed further towards updating. So Now we have to do eTag checks. So as part of eTag checks, what we need to do, read the last changed value from the table. And here the table which is being used, guys, is SEPM underscore IEOE. This is the table ISOE, sales order dates, change dates and changed and updated dates. This is the database table where it's stored. We read the last change value, and we also read the if match value from the request header, which the client is passing you, because we have implemented already the eTag feature. And once we find that, compare both of them. So now you are basically checking whether the last state which you have given initially to client 1, maybe let's say client 1 asked for read one sales order for updating, and you have sent an eTag. And at the same time, client 2 also requested for the same sales order, and you have sent also the same eTag to this gentleman, client 2. So both the client 1 and client 2 has same eTag, let's say X at this point of time. And now that's also in the server. The state of the eTag is X, which is last change date and time. And now client 1 updates this. So when client 1 updates, client 1 is sending X to the server and says, hey, this is the current eTag you've sent me. Is it valid? Server says, yes, it's matching with what I have. This is the latest state of the object. And server makes an update. After server makes an update, it makes the eTag value as Y. And later point of time, client 2 comes back saying for another update. Now, once again, server does the same thing. It treats that request also in the same way. It checks whether the eTag which was sent initially is that state same as the new state. Not throw an exception and tell the client to, hey, in the meantime, while you were editing your object, somebody else have updated the same object, and now I have a new state of the object. Would you like to reload the state, or would you like to overwrite? So these are the kind of option we can offer to the client too, and that's what we will be doing in next step. In next step, we will be doing the same thing. I'll be implementing a Fiori application, and I will show you end to end how all this orchestration will take place. But right now, we are completely focusing on the server side, and this entire logic of orchestration needs to be done on the server side. So this is what exactly we will be implementing on server side. You're getting the compare both of them, both the eTags, the one which you receive from if match header, which client passes to you, and the one which you have already in the server as changed last change value. If this matches, we can proceed with update, which means the state which client has is same state as the server has. If it does not, we need to throw an exception and tell the system, hey, there was somebody else who have changed in the meantime the object which you are now requesting for a change. So that's the complete algorithm. And guys, just in case if you cannot do this update at this point of time because the state is changed, you got to release the lock. Very important. So release the lock manually and just go on. But in case of the update needs to be done, we can proceed with update. Sorry, in case we cannot update, in that case we are throwing an exception. So lock needs to be released by yourself on your own. You need to release the lock and then throw an exception nicely. But if update can be done, update takes place, the method naturally comes out and the lock automatically gets deleted from the gateway system. All right, so that's the complete flow. And this is our algorithm for the implementation of both the checking for deletion, concurrent update, if object is deleted, the first important thing. The second important thing is putting an optimistic lock only at the record level. And then the third step is finally to compare the eTag values and find out if the state of the object has been changed over a period of time. If not, then probably go ahead with update. If the state is changed, throw an exception and don't let them update now. All right, so let's go back to the system, and now we will be implementing this complete algorithm as it is as part of our update entity set method. So I will copy this code and paste that into our method over here. So we'll be adding the logic over here. And now we will be writing each of the steps carefully. So let's comment out this code. These are all steps for implementation. The very first thing, we got to check if the sales order does exist into the system. And if it does not, we got to immediately throw an exception over here. So the check for that will be done as part of SNWD SO table. Guys, just try to remember, this is based out of EPM data model. EPM data model is mainly for demo and training purpose. It is not for productive scenarios. Usually you will be doing this real-time implementation as part of your VBAP table, which is actually containing the sales order information in a ERP system. All right, let's come here and we'll do a select single. And I'll just do a check into my inline data declaration. And that's something, a good way of checking something. Where my sales order does exist or not. I got to check in the system if I have a sales order exist or not. For that, I will just put SOID key values -sales order. If it does exist, very good, we got to proceed. If it does not, then we have to throw an exception. So we have to check LD exist. If it is not equals to blank, we got to throw an exception. Yeah. So what is inline data declaration? Once again, I would like to remind you, you can subscribe to my ABAP on HANA training to understand new inline ABAP syntax, including a lot of interesting topics on ABAP on HANA and S4 HANA. All right, let's put an exception handling here. We got to implement a suitable exception. So let's do that. I'm going to create a message class ls message. I've already done that already on the top. And I hope it's already created. Not created, then we got to create one ls message. And this message will be of type your T100 keys. That's what we will be doing, SCX_. That's a standard type for all the messages which you're going to trace from message class. It has got a message ID, which is SI class, is a standard system class for messages. Message number, I'm going to use a default message number 2. And then I'm going to concatenate and I'll say update for sales order. And my sales order value failed as object not found. Attribute 1, and then finally throw an exception. And you can also check the exception class name already in the signature of gateway method over here, and we'll throw this exception here. So automatic code generation, and in the text ID we will pass this structure for message. All right, so that's the exception handling. If not exist during concurrency, if somebody in the meantime have deleted that sales order, in the concurrency system will get this error message that doesn't exist. All right, moving next part, we got to now try to lock the object. Now, in order to lock the object, first of all, we need to prepare the lock arguments. For that, I'm going to use a basis module to prepare all my initial lock arguments. So call enqueue wildcard. This is how we initialize lock arguments in SAP system. And now we will be just putting some property values inside the BO name. So there is a dedicated business object exists today in the system, which we are referring to IFEPM-SO, Enterprise Procurement Model for Sales Order. Then we have the BO node name, which is IM EPM sales order header. Header node is what is we are referring to, and the client value will be psi-mandate. It's a current client value. And now with this object, we will try to enqueue. We will try to lock the object. All right. Now the node key is going to come from the node key object of the payload. So that's where we will receive the node key, because we are already going to query that. All right. Maybe I will query that directly here. Maybe I will just try to say into select single sales order ID into LV exist. And if LV exist is not equals to, or if it is equals to blank, then the object not found. If it is there, something is there in LV exist in the sales order ID, which is essentially sales order ID, then we are good to go. All right, so let's take that up, and I will say ls snwd lock hyphen node key, and that's going to be my sales order ID, which I'm passing to the node key to lock the sales order. Now let's try to acquire the lock. And we all know there's a enqueue function module which exists for lock objects, and there is also a dedicated lock object function module offered by SAP for EPM data model for sales order object. It's called enqueue EPM lock. And you see it has generated the signature already for that. And now we will be passing all the lock arguments, and this is going to be an exclusive lock for this period of time. So let's pass these arguments: node key, BO name, BO name, and client field. So let's pass this BO name over here, BO node name over here, and node key over here. All of that we are passing up, and then we are going to catch these exceptions. Just in case any of the exception comes, we know what we got to do. We got to transform this exception now to OData, and we should give an error saying that, hey, I could not acquire the lock. So once again, this is a repetitive code. I'm going to reuse the code which I've written on the top to save some time. And now we will just say unable to acquire lock on sales order number. What is the number? That's what we will give, and we'll give this as an error. Awesome. And throw an exception one more time. Awesome, guys. So that's the step number 3. And we try to acquire the lock. If the lock could not be acquired, then we throw an exception. Else, we got to move on. And now it's time to compare. Read what was the last updated eTag value. Basically, what was the last change date and time for that sales order. And then based on that, we are going to compare that with the input eTag which client is sending to us. So let's find out. Let's get the value of the eTag from the last change value from the sales order table, sales order ISOE table. So I will say select single. And as we know, we are working on a BAP on HANA. It's a good practice that you always use the field which you are really interested. So I want just last changed date time from SEPM underscore ISOE table. That's the table name which we are using. And into inline data declaration as usual. Let's say LV eTag. This is the value which server holds about the eTag, where sales order is equals to my key value, and that key value comes from the top already. We are reading these key values here, and let's put that over here and just mention sales order. Awesome, guys. So now we are reading the eTag value over here, and we will be checking if this eTag value is matching with the value what client is sending to you. So client also sends you the value. How do you read them? So we're going to read them from IO tech request context object, and there is a method called get condition info. And now there you got the conditions, and I've already declared a data type for catching these conditions into a variable. And let's compare both of them. So we got a loop over this. if match. So that's what we got to loop our if match into inline data declaration called ls tag. So that's the tag which client is sending, and now we need to compare this tag with the tag what we have in the database. So whatever is there in server, that needs to be compared with what client is sending to you. So let's compare that, and you can also do that with just a read statement. I can simply compare this with the if statement. So if my tag value which I have, is it matching with the tag value on the database? So let's check this ls tag iPhone, and I think what value we need to compare, it's I think any value, tag value. If this matches with the value what I have in database, then we are good, which means the object is still intact. So I will say LV, and let me just use a variable here, tag value, and I'll say LV matched. Matched is true. We mark it as true, and we exit out from the loop. Else, we got to make the LV matched is above false. So now the tag is not matching, which means somebody in the meantime, another client or another user would have already updated the timestamp, or he would have updated the sales order. And because of that, the tag value have changed. What this client is now sending to me is something which is outdated. Somebody in the meantime have already changed. So that's a false. And then finally, we come down and we compare now and check if this is true or false. If this is false, then we are going to release the lock and throw an exception. So if it does not match, throw an exception and release the lock manually. That's the step. And just comparing this, say if match is false, then we got to release the lock. So we have to call DQ EPM lock. So instead of NQ, say DQ. And we will be releasing this lock quickly. So let me just bring all those arguments one more time over here and just release the locks which we have acquired. Superb. So that was the lock I've acquired, and now I'm going to throw an exception after releasing that lock. So let me throw an exception right away here, saying that, hey, something is really not right. You guys are trying to update something which was already changed by another user. So we will be raising one more time this business exception. So raise exception, this, type. And what I will do is I will here put the HTTP status code as precondition field. That is what we say to the system wherever somebody says, okay, is it because of if mismatch not matching actually. So if the tag is not matching, we are going to throw this exception. So let's pass this exception HTTP code and text ID and HTTP status code here, and that's going to be because of the tag mismatch. We are throwing this exception after comparing the tag. So the message ID here will be from the standard one, which is /IWBEP /C business exception class, and then there is a precondition field type which I can use. Yeah. All right. And then we will also use the status code from the class. So let me just use status code. You can find all the HTTP status codes as part of this class in something called GCS HTTP status code. Global constant is there, and this you can find precondition field. Awesome. So that's what we have put now. This is going to be my standard exception, which is going to go out in case the tags doesn't match. I release also the lock before doing anything. And now, guys, if everything goes good, nothing needs to be done. Pretty easy, straightforward. That logic is already in there. No exception comes. Everything is smooth. Please go ahead and update and trigger, or please save this up. We are done. Congratulations. That's the implementation of code to be able to, oops, I have a syntax error. Let me just go for edit. Okay, ls message already declared, no problem. I just delete that. So once again, guys, this entire code will be available on my website exclusively, absolutely free for all of you. You can find the description here on the website right away. All right, so let me quickly correct out these errors. So because of now new features which ABAP language has, we got to implement these things over here. All right, so let me also fix this guy, this gentleman. It's LV date and time, and this should be moved to the tag data type. So the data type is mismatching, so tag value, eTag value is equals to this guy, and then this needs to be completed here. All right, awesome. Let's check this up. Okay, both cannot be compared. There is something wrong. We have to check the data types. What is the data type for this guy, this tag value, and is it matching with this guy? So let me check the tag value data type, and it's of type this TYT eTag value, and just go to this structure, and there is something called a value which we have to compare with that value. All right, so I have to come back here, tag values. I think once again we got to loop over these tag values and then compare that. So we have to read table tag values into data ls tag values with key name, and the name here for the tag is whatever name of the tag we have that we have to give here, and then accordingly we got to come, and that's of course the last change date and time. That's the tag, and we got this in this structure, and here is where we'll compare this value with the tag value. Awesome. Let's do a save and check one more time. Looks all good, and let's activate our code. So of course we cannot test this code right away here. Of course you got to, once again, if you wish to test, you can go ahead and test it with 2 parallel sessions of your gateway client. But what makes more sense for us is to use a Fiori application. So now we will be building a Fiori application on top of this entire scenario, and then simulate this scenario by running the same Fiori application in 2 sessions, and see how concurrency can be managed, how when 2 users are connecting back to back with your application, how can you manage the eTags, how can you check them, and how can you orchestrate these requests in hand-to-hand with the backend system. So that's what we will be doing next, guys. So let's go to the next session, and we will achieve that. So stay tuned on my channel. Please subscribe to this YouTube channel if you've not done that. For most of the interesting and new videos on ABAP on HANA and S4HANA, including UI5 Fiori, you can always come back to my channel. I would highly recommend all of you to subscribe to my entire UI5 Fiori training plus ABAP on HANA training. If you have not seen the video which I published long back about how to become SAP Full Stack Developer, please do watch that. I encourage all of you to at least watch that video, because most of us today are able to understand things, are able to see there is a change in industry, but unable to find out what kind of change, how will it affect us as a developer, and what are all the salary prospects of the learning. So this is why, which is very important, you must watch this video, how to become SAP Full Stack Developer and what should be a learning map for these future technologies. With that, Anubhav signing out. Thank you so much. Stay tuned. You can look at here. Do leave your comments here. Let me know what is the biggest challenge in this POC you are currently facing, which I'm showing here. Is there any questions you have in your mind? Please do write them in the comment box, and I will love to reply on your comments. Thank you so much again. Have a nice day.